Hello grade 12s, welcome back to it. It's Maths Masterclass with Leo. If you are new to the channel, please don't forget to subscribe and like my videos. Comment if you have a problem. You can just comment down below your question and then we'll attend to it. Thank you. Okay, today we will be doing a very important part of maths, a very important. And this is my favorite topic actually on maths. It's functions. Right? Functions. By now, you know that in paper 1 we have 4 functions. The first one, it is the linear function, which is the simplest, y is equal to mx plus c. The second one, it is the parabola function. The third one, what we have the hyperbola or hyperbolic function, and then number 4 we have the inverse function, right? Then we'll have those others later, the what you call polynomials. Remember polynomials, they also are part of the functions. You'll also have trig functions, but today or in this video we will be focusing on this 4, right? Linear pattern, or sorry, not pattern, linear functions. What you need to know is this, m. What is your m? This, we call it your gradient, right? And then remember, when calculating the gradient, you need to say m is equals to y2 subtract y1 all over x2 subtract x1. That is how you calculate your gradient, right? And another thing that you need to know about your gradient, if your gradient is greater than 2, is greater than 0, not 2. Where did I get 2? It means I love 2 very much, hey? Okay, now if your gradient is greater than 2, if your gradient is greater than 0, this is the graph that you will have. Why is my graph like this? This is what you call a positive gradient graph. This is a positive gradient graph. My graph is an increasing function, or an increasing graph. It's an increasing function. Why do I say it's an increasing function? If you can check, here I'm going to have my x negative, here I'm going to have my x positive, this is my y positive, y negative, right? If you check, when the x values increase, also the y values increase. As you can check, we're moving from negative x to a positive x. This is where we are going, right? We're moving from negative y to positive y as well. That is why I'm saying, if your gradient is greater than 0, if your gradient is positive, then these are the conditions that you will have, right? Your graph should be an increasing function. Again, value of when reason being, if the value of x are increasing, also the y values are increasing. That is why we have our graph as a increasing function, right? Okay, now if your gradient is m less than 0, meaning your gradient is negative, then it means you're going to have the opposite of that. We're going to have a decreasing function. This is my x negative, x positive, y positive, y negative, right? This is the type of graph you will have. Right? If you can check, when the x values increase, the y values decrease, right? You can check, we're moving from negative to positive. When the x values increase, the y values decrease, right? If you can see, x values are increasing, are going up, but y values are going down, from positive y to negative y, right? And again, if you can check, this is a straight line, Meaning the equation for a straight line, you can write it like this: mx plus c, right? This is the equation for straight line. Now, remember, f of x can be represented by y. So it means I can just write it like this: mx plus c, right? Remember, always when you deal with these things, you need to know this two gentlemen, these two gentlemen, the domain and the range, right? You need to know the domain and the range. What is domain? What is range? Domain, the set of x values. Domain, let me just write the definition here so that everyone knows it. Domain is the set of x values, right? Then range, it is the set of y values, right? And the domain and the range for a straight line graph. The domain and the range for a straight line graph. The domain will always be like this: x belongs to real numbers. What does that mean? When they say x belongs to real numbers, my value of x, I can find the value of the graph lies in between the negative and the positive values of x, right? My graph lies in between the negative and the positive values of x. That is the reason I'm saying x is the element of real numbers, right? Again, my range is y is the element of real numbers, right? Y is the element of real numbers. Why do I say that? If you can check, my graph lies in between the negative and the positive part of x. My graph lies, not x but y. My graph lies in the negative y and positive y, right? Hence I say y is the element of real numbers, right? Okay, now let's move to, I hope I covered almost everything in this. Oh, not everything, but I still need to talk about these ones. But in most cases, these ones will come when we do analytical geometry, right? Where we say, what is M1? Why do I say gradient at 1 is equal to the gradient at 2? How do I identify that? Okay, now, if I have, okay, let me just say again, equals to the gradient at 3. Let me say this is my Cartesian plane, this is y positive, this is y negative, this is y negative, this is x negative, this is x positive, right? Let me say I have that is my graph. Let me say I have a graph like that, right? I have a graph like that. This here is my M1. This here is my M2. This here is my M3. M1 equals to M2 equals to M3. Reason being, they are collinear. Right? What does collinear mean? They lie in the same graph. My gradients lie in the same graph. The gradients that lie on the same graph will always be equal, right? The gradients that lie on the same graph will always be equal. I hope you understand. Then now, let's take another one that says M1 is equal to M2, right? M1 is equal to M2, and let's draw our Cartesian plane again. This is my y positive, y negative, x positive, right? I have two graphs. This is my first graph, right? This is my first graph. This graph is parallel to this graph, right? These two graphs are parallel. Let me say this is my f graph, this is my g, right? Graph of f is parallel to graph of g. Then I have a gradient here. I need the gradient of g. I have the gradient of f, I need the gradient of g. Because these two things are parallel, then the gradient of f is equal to the gradient at g, right? The gradient at f is equal to the gradient at g. because these two things are parallel. When you have two parallel lines, or when you have two parallel functions, their gradients will always be equal. The gradients of the two parallel lines or parallel functions will always be equal. I hope you understand. Let's take another one. Let me just draw. Okay, they say m1 multiplied by m2 equals to -1, right? m1 multiplied by m2 equals to -1. Then let me just draw my Cartesian plane. My Cartesian plane, y plus y minus, then okay, x minus x plus, right? This is my graph. I have okay, this is my function. Let me just call it what, f. That is my function f, and then let's draw another function, call it g. This is my, this is my function, right? Okay, this is my function going that way. This, it's like that, right? Let's call this one g. The gradient of f multiplied by the gradient of g, they should give me -1. Why? Because the two are perpendicular. The two are perpendicular. If you have two perpendicular functions, the gradient of the two, or the product of their gradients, the product of their gradients is equal to -1. The product of the two gradients of the two graphs, the product of the two gradients of the two graphs is equal to -1. I hope you understand. These are the basics of linear pattern, right? You should know them. They'll also be there on your, what you call, on your analytical geometry, right? Okay, now we have the last one, which is, okay, the gradient equals to my tangent theta, right? The gradient equals to my tangent theta, right? And again, what you need to know, if they say the gradient is equals to my tangent theta, they mean from this point to this point is my theta, right? And if you find your angle, find your theta as negative, always add 180 degrees so that it becomes positive, right? If you find your theta as negative, always add 180 so that it becomes positive, because this angle is always drawn from the positive x-axis. This theta is always drawn from positive x-axis, meaning from this point, from this line. Always, you can never find your theta drawn from this line going that way, right? You will never. So if you get your theta as negative, it means it will be something like drawn from this way. When you need to correct it and say, oh, my theta is negative, so I need to add 180 so that my theta becomes positive, right? Okay, let us continue. Now I want us to do basics of parabola. Then we'll take questions from both of them, because in most cases they will combine two functions. It's either they'll combine a straight line and a parabola, a straight line and an exponential function, or vice versa. In most cases, that's what they'll do. They'll never ask you single questions like maybe they'll say calculate get the equation for the straight line, all these things from the straight line. No, they'll mix them. They'll either take questions from parabola and hyperbola or other graphs. Okay, now let's continue. Let's do basics of a parabola. A parabola, right? We all know the general equation for a parabola, which is y is equals to ax squared plus bx plus c, right? what I forgot in the previous class, not in the previous class, in the previous function, it's this, right? A constant. A constant will always represent the y-intercept. A constant will always represent the y-intercept, right? If you have y is equals to mx plus c, this represents a constant, right? As a constant, it represents y-intercept. Okay, some of you might be asking, what is a y-intercept? Okay, if I have a graph like this, if I have a graph like that, this is my y plus, my y minus, my x minus, and my x plus. If I have a graph like this, then my graph touches that. Y-intercept, it is this point. Y-intercept, it is this point. This point represents the value of c, right? This point represents the value of c, and not in most cases, always at a y-intercept. At a y-intercept, the value of x is equal to 0. Similarly, here, this is the x-intercept. X-intercept, the y values here are equals to 0, right? Okay, now, I wanted just to clarify that. Let's continue. I have this. This is the general equation for the parabola, right? This is the general equation for the parabola. And then you have a parabola like this, right? You have a parabola like this, and then the shape of your parabola, that's something like that, right? Something like that. And then if you have something like this, you have the y-intercept. This is the y-intercept, and then this is the turning point, right? You have the turning point. If you have the y-intercept and the turning point, you can use this equation. Y is equals to a into x minus p squared plus q, right? This represents p is 2 minus q, right? This represents the turning point. That is the turning point. Now, you have a graph like this. You have a graph like this, there, right? You are not told these points. You are not told the turning point, but you know this point and this point, right? You know that those 2 points, you can use this equation. Y is equals to a into x minus x1, x minus x2, right? You can use this equation. Then now, what is a? A represents the shape of the graph. A represents the shape of the graph, right? Okay, now if your a is greater than 0, what does that mean? If your a is positive, is greater than 0, that is what we call a smiley face, right? That is a smiley face. This is the graph that I was drawing. You're gonna have a graph like this, right? You're gonna have a graph like that. Now, if the value of a is less than 0, meaning the value of a is negative, then you're gonna have a sad face, right? Then what is the shape of the sad face? This is the sad face, right? Meaning your graph, the concavity of your graph will be facing down, right? This is what you call concave down. This is concave up, right? The concavity of the graph is facing down at this point, and then the concavity is facing up at this point, right? Similarly, okay, if you are given the equation, you have everything like this. You are given something like that, okay, then you're given that this is x squared, maybe plus 2x plus 4. They say calculate or determine the turning point. of this equation. Determine the turning point of this equation, this part, right? How are you going to determine the turning point? The equation for the turning point is x is equals to minus b divided by 2a. This is the equation of the TP, right? The equation of the turning point. Now, similarly to the graphs that we were doing, similarly to the graph that we did, the linear function, if you have a graph like this, okay, now your graph is like this. They say this is the point is 0 is to 1. Ne? They gave you those points. They say what is your, or write down the domain and range of the graph. The domain and range of the graph. In most cases, the domain for a parabola, this is 1 mark. But this one is 2 marks. Right? The range. Why do I say the range is 2 marks? Look. Domain. What is my domain? If you can check, my graph lies between the negative x and the positive x. This is the negative part of it. This is the positive part of it. Right? This is where it lies in the negative part. This is where it lies in the positive part. Right? Now, I'm just going to say the domain is x, is the element of real numbers. Why? Because it lies between the two. This is my 1 mark. Right? Now, what is the range? Can I say y is the element of real numbers? No, this is wrong. You cannot say y is the element of real numbers. Why? If you can check, your graph it's not there in the negative part of y. It is only in the positive part of y. Right? It only exists in the positive part of y. So I cannot say range is y is the element of real numbers. This is going to be wrong. This is wrong for this graph. Ne? This is wrong. So what am I going to say? What is my range? What is my range? Now, my graph, if you can check, my graph lies between 1 to positive infinity. Right? It starts at 1, it ends at positive infinity. Right? This is my 2 marks. These are my 2 marks. Or I can write it like this and say, oh, because it lies between 1 and positive infinity, I can just say, oh, my graph is in between 1 less than equal to. Why do I say less than equal to? My graph starts at 1. 1 is also included, right? 1 is also included. And then, what am I talking about? It's my range, y, right? Less than infinity. Why do I leave this thing? Why can't I say less than equal to? It will never touch infinity. This is included when you say my graph starts at, or my graph touches that point. So my graph will never touch infinity. So now that is why I have 1 less than equal to y less than infinity. I hope you understand. Now, I believe we have covered everything. Let me just check my notes first and then I'll tell you. Okay, but we did touch on it. Let me just emphasize it again. This one. If you have a graph like this is your graph. Then your graph is like that. Right? This point, we call it, this represents the value of C. This is the Y-intercept. Y-intercept. Right? Let me just emphasize it. This is the Y-intercept. And this two, they represent the X-intercepts. Now, we need to talk about this guy as well. Okay, having a graph like that, then we have this supposed to be a perfect. This is what we call, I want to talk about the line of symmetry, but my graph is not perfect. Okay, this is what we call the line of symmetry. From this point to this point is equal to from this point to this point, right? Means this cuts the graph into two equal halves, right? Okay, now we did the introduction. I hope you enjoyed it, and on the next video I'm going to explain the questions. I'm going to take questions and then explain them. Then after that we will move to the next two graphs, and I hope you enjoy your day. Thank you for watching the video. Have a wonderful day. Tango.